general relativity step by step. Got this nice little coordinate system x and t here, and let's just say I've got an event E1 and another event E2. An event E1 is characterized by t, x, y and z, so it's got its time and its 3 Cartesian coordinates there. It's a little bit tricky because I can't actually draw oh, that's a z, x, y, that's supposed to be a z. I can't really draw those. I can only draw the time in the x direction, but you can see that I'm indexing an event by its 4 coordinates there, and that's E1. E2 is going to be t plus delta t, x plus delta x, y plus delta y, and z plus delta z, and that's going to be event E2. So I've got E1 and E2, and I will define the interval delta s squared between E1 and E2 as follows. Delta s squared equals minus delta t squared plus delta x squared plus delta y squared plus delta z squared. That's just an arbitrary definition. That's just an arbitrary definition. This is an interesting and useful thing to want to define. So what I'm going to do is I'm going to spend a little bit of time talking about it and a little bit of time trying to work out how it transforms when we change our coordinate system. But for the moment, what I want to observe is that if I set up my coordinate system x and t, oops, I keep on drawing y, t, there he is, the little person standing there, and if I draw a light beam going along there, then I know, if I go back to black, along the light beam, when I say on, I mean E1 and E2 are joined by a light path, by a path of light, of a photon, I guess. On the light beam, delta s squared, no, on the light beam we know that delta t equals plus or minus delta x. I guess you've got the two signs, you've got the plus or minus, one going leftwards, and if you want the negative sign, that's going the other way, that's going backwards. Going back to black here. So that tells me that delta t squared equals delta x squared, and that tells me that delta, well, let's just do it in one dimension, minus delta x squared equals 0. But of course you can easily see that delta t squared minus delta x squared delta y squared minus delta z squared is also equal to 0. So that's delta s squared equals that. Okay, and I'm just defining this as the I'm just defining that as the interval. I could define lots of things, but the reason this is interesting is that it is invariant. The interval delta s squared is the same for all observers. So what does that mean? That means that if I set up my coordinates here, x and t, and I've got a couple of events here, I'll write these in, what colour is this? That's green, that's E1, and another event E2. I can calculate delta, oops, go back to black. I can calculate delta s squared equals some particular thing, and then I can ask, well, hang on a minute, what does my mate say who's in his spaceship? There he is in his spaceship cruising along. What does he make? Well, he says that delta s bar squared, the bar meaning the blue coordinates, equals some other thing, because he will have a different description for E1 and E2. It's going to be the same thing. Not the same thing, it's just going to be the same quantity. It's going to be the same value for both observers, which means it's an interesting and useful thing because it does not vary depending upon what observer you are choosing or what coordinate system you are choosing to describe your events E1 and E2. This is going to take quite a long time. There's quite a lot going on here. So I just want to make sure I've got everything set up. We define our interval delta s squared equals this, and then I'm observing that on the light beam delta s squared equals 0. Have I written that down? Yes. I'm also going to observe that delta, wrong colour, just a minute. I'm also going to observe that delta S squared equals 0 implies delta S bar squared equals 0. Because if two events are on a light beam or are connected by a photon path for one observer, they are connected by a photon path for all observers because the laws of physics are the same for everyone. So that's got to be an implication the other way as well, because if delta S bar squared is equal to 0, that tells me that delta S squared is equal to 0. So if it's 0 for one observer, if delta S squared equals 0 for someone, for anyone, for any observer, then delta S squared equals 0 for all observers. Because the speed of light is constant for everyone. And I'm going to stop there. Stop. And I'll prove it's the same in the next screencast, or it might take me two. I haven't decided yet. Stop.